Hey everyone, and welcome to this explainer. I am absolutely thrilled you're joining me today because we are going to look at one of the most fascinating intersections in modern science, the collision of cutting-edge artificial intelligence with fundamental human biology. We're talking about the very beginnings of life itself and how technology is stepping in to assist, refine, and totally revolutionize the deeply personal journey of building a family.
I mean, it's a profoundly deep question, isn't it? Can an algorithm actually help create human life? For decades, Assisted Reproductive Technology, or ART, has relied incredibly heavily on human intuition, incredibly steady hands, and meticulous microscopic observation. But as we're going to see today, we are rapidly entering an era where machines are finding a profound, irreplaceable spot within the most deeply human process imaginable.
So here's a quick roadmap of what we're covering today. We'll start with Section 1, the IVF subjectivity problem. Then we'll move right into Section 2, grading eggs and sperm. In Section 3, we'll explore Embryo Selection 2.0, followed by Section 4, the AI outcome lift, and finally, Section 5 will cover ethical AI and fertility. Let's just dive right in.
To really grasp why this technology is such a massive game changer, we need to kick things off with Section 1, the IVF subjectivity problem.
You see, for years, the traditional practice of IVF has faced some really massive hurdles. Just try to put yourself in the shoes of an expert embryologist for a second. You are staring through a microscope for hours on end, analyzing these subtly shifting cells. It is, no joke, like trying to solve a microscopic magic eye puzzle for 12 hours straight. And the first major challenge that comes with that is subjectivity. There is a ton of high variability in embryo grading. That means two brilliant embryologists might look at the exact same embryo and give it two completely different grades. On top of that, it's just incredibly time-intensive manual labor to monitor everything. And let's be real here, human beings get tired. Fatigue inevitably sets in, and when fatigue sets in, the potential for error naturally rises. Plus, the human eye, no matter how highly trained, simply has limitations when it comes to identifying the incredibly subtle morphological patterns that are linked to successful implantation. All of this can make the process clinically imprecise, and for the patients waiting by the phone for those updates, well, it's incredibly emotionally exhausting.
So how exactly do we fix this? Let's move over to Section 2, grading eggs and sperm, where we look at the individual ingredients.
During processes like ICSI, where a single sperm is injected directly into an egg, identifying the absolute optimal gamete is critical. And this is where AI-driven platforms like Sperm ID step in to automate the entire selection process. Using advanced computer vision, the system tracks sperm motility, meaning how they move, and their morphometry, which is their shape and structure, all in real time. The algorithm can instantly classify them from low to medium to good and finally to best. So what used to be a highly subjective guess is completely transformed. In fact, the data shows 100% efficacy in parameter evaluation here, which totally standardizes the process and drastically reduces that operator variability we talked about.
And of course, the other half of the equation is the egg, or the oocyte. Historically, doctors could really only tell if an egg was mature or immature. But today, new computer vision tools evaluate oocytes right at the time of retrieval to predict their long-term developmental potential. Platforms like Future Fertility look at incredibly microscopic details, things like cytoplasmic features and the thickness of the zona pellucida, which is the outer membrane of the egg. By providing an individualized score right at the very beginning, clinicians can manage patient expectations from day one of the cycle. You aren't sitting around waiting weeks to find out if the foundational building blocks were viable. The AI gives you an objective assessment immediately. It's truly amazing.
Now, once fertilization occurs, we move from the ingredients to the product itself. That brings us to Section 3, Embryo Selection 2.0.
This is where we see the massive leap from human observation to machine learning. Instead of pulling an embryo out of an incubator once a day to grade its morphology, which is basically just taking a static snapshot, deep learning models now analyze continuous time-lapse videos. This specific field is called morphokinetics. AI models, like IDAScore or Erica, are constantly watching these time-lapse videos, tracking literally thousands of developmental data points that the human eye simply couldn't catch in real time. Because it's an algorithm, it provides a totally consistent ranking across an entire cohort of embryos. It can even identify the risk of aneuploidy, which are chromosomal abnormalities. Ultimately, the AI synthesizes all these thousands of invisible data points into one clear, objective chance of pregnancy score.
Okay, let's zoom out from the microscopic petri dish for a minute to see what this actually means for the clinic itself. Welcome to Section 4, the AI Outcome Lift.
Boom! A 25% increase in viability prediction. When an algorithm is tracking thousands of microscopic morphokinetic data points instead of relying on a human snapshot, we see a massive jump in accurately predicting exactly which embryo will thrive and lead to a successful pregnancy.
And alongside those vastly better predictions, we also see a 50% reduction in lab workload. AI essentially takes over the tedious, repetitive manual labor of counting cells and watching time lapses. This is huge because it frees up those brilliant embryologists to focus on the high-level, complex tasks where human expertise is genuinely irreplaceable.
Now, the really crucial point here is scale. These algorithms aren't just taking wild guesses. They are trained on data sets of over 10,000 embryos. By leveraging this massive, standardized history of clinical data, AI is effectively reducing clinic-to-clinic variability. Whether you're getting treated at a top-tier clinic in New York or a smaller regional center, the AI applies the exact same standardized high-level criteria to your care.
And let's be super clear, the AI lift isn't just happening inside the embryology lab. It's actually optimizing the entire patient journey through precision stimulation protocols. Even before the eggs are retrieved, AI integrates a patient's age and hormone levels, like the ovarian reserve hormones AMH and FSH, to precisely optimize drug dosing. It predicts ovarian response to refine exactly how much medication is needed. It helps identify the perfect trigger timing, pinpointing when follicles are in that exact sweet spot of 13 to 18 millimeters to yield mature eggs. It even uses smart algorithms to optimize clinic workflow and schedule patient appointments based on these real-time physiological markers.
So here is the absolute key takeaway. When we look at outcome prediction accuracy, a traditional embryologist working alone sits at about 67% accuracy. If you hand the process entirely over to an AI working alone retrospectively, it actually bumps up to 75%. But when we combine them into a hybrid model, AI and human working together, the accuracy hits a staggering 90%. I mean, wow. The data definitively indicates that AI is most effective not as a replacement for doctors, but as an incredibly powerful decision support tool. When the empathy, the context, and the steady hands of a human expert are augmented by the massive data processing power of an algorithm, the results are simply unprecedented.
Now, as incredibly exciting as a 90% accuracy rate is, we do have to pause for a second. Let's talk about Section 5, Ethical AI in Fertility.
With this kind of power, there are two major limitations we absolutely have to grapple with. The first is what we call the black box problem. This refers to the real challenge of understanding exactly how deep learning models actually make their decisions. Because if an AI gives an embryo a low score, a doctor needs to be able to explain why to the patient. We are shifting from non-explainable AI to explainable AI, because transparency is absolutely key to maintaining clinical accountability and, most importantly, patient trust. The second big issue is algorithmic bias. If an AI model is trained entirely on a specific demographic population, say only patients from one specific region or ethnicity, that model might completely fail to generalize across diverse demographics. To fix this, there is a crucial, ongoing requirement for multi-center validation across the globe, along with strict regulatory oversight to ensure the AI works fairly for absolutely everyone.
Which really brings us to our final thought. The technology is here, right now, and it is provably increasing the chances of creating life. But the real question is, are patients ready to trust their family planning to a machine? It's a very delicate balance. We want the algorithmic precision that a machine provides, but we desperately need the human empathy that only a doctor can offer. AI is revolutionizing fertility, not by taking the human element out, but by giving it the ultimate tool to succeed. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll catch you next time.